Welcome to Thevenin Review. All right, we're going to Thevenize this circuit. We're looking at this RL as our load. First thing we want to do is draw a simple series circuit, which represents the Thevenin circuit. Got V Thevenin, R Thevenin, and then we put our RL back in. So there's our simple series circuit. Now, R Thevenin, we can do either one of these in either order, but R Thevenin is going to be equal to, we're going to pull the load. Imagine that the load has been removed, and we've got point A and point B. So we can see if we Thevenize from point A back to point B, we've got R2 in parallel with R3, and add that to in series with R1. For V Thevenin, sometimes it's easier to do a little redraw for V Thevenin. So we've got E, R1, got R2 and R3. And from that point right there, RL has been removed, so we've got a break in the circuit. If we have a break in the circuit from here to here, we know that there's no circuit current, so if we Kirchhoff back, we see that the voltage that should be seen from that point, those 2 points, would actually be E. So we know that V Thevenin is equal to E in this circuit. And now we can put V Thevenin in, we put our R Thevenin in, we've got our RL, and we can find the IRL, we can find the VRL, and solve for the voltage and current through this load resistor right here, RL. Okay, now we're going to Thevenize for a bridge. First thing, again, we want to redraw our circuit, our simple series circuit, V Thev, R Thev, and RL. To solve for our Thevenin, we're going to pull the load, call this A, this B, and we can see that if we go to this node right here, trying to get back to B, we've got, redraw that looks like, let's go ahead and redraw that. Okay. We can see that this point on the other side of R1 and R2, that those, once we get here, that those 2 points electrically are the same through the DC supply. And as we come back to those points, so if we call this like point A, or just call this some other, probably something other than point A, but call this some point like X. So that means we've got X here, and X here, and X here, and X here. It's all the same point. So once we're at that point, they're all physically connected, and we can see that in order to get back to B, we've got to go through R4, R3, and R4. Now we're back to point B. So that's our R7N redraw. The tricky part is right here in the middle where all those nodes kind of come back together. So if we want to write that formula, move that over a little bit. R1 in parallel with R2 plus R3 in parallel with R4. There's our R7N. So V-Thevenin. Let's erase all this. V-Thevenin is, I like to do a redraw for that also. So if here's my supply. Because the load is pulled, so we have this point A, point B. That's where our load is connected. So we want to find the voltage from point A to point B. That's our Thevenin voltage. Now the other thing you want to do is make sure you keep track of the polarities, because based on the polarities, so let's say if this side was more positive than this side, or the other way around, that's what your final polarity is going to be on the schematic. Left to right, right to left, whatever it is, just keep track of it, because that'll be the polarity on the schematic also. Okay, so now it's just two series branches where you're going to find the voltages here. And then you're going to write a Kirchhoff equation, either this way or this way, either way. And I actually recommend doing both because you should end up getting the same answer. And then now with that voltage, that's your V-Thevenin. So you're going to Kirchhoff find V-Thevenin. So voltage from point A to B. So V-Thevenin is equal to the voltage from point A to B. And now you can put it into your simple series circuit. You've got your V-Thevenin, you've got your R-Thevenin. You can find your current through your load resistor. You know the polarity, and you can find the voltage across RL as well.